To look at line graphs. By now you should know what a line graph looks like, and you should also know how to draw a line graph with the necessary elements on your graph. Okay, so let's have a look. Line graphs are useful when showing upward and downward trends in data. They are also useful for finding in-between values when the quantity on the whole. Back in a couple of years ago, you may have looked at types of variables. Line graphs are good for numerical continuous data. Example 25, constructing a line graph. Okay, so here we've got a table which shows the variation in price of a share at end of trading for each day over 1 week. Draw a line graph to show this information. Okay, so simple exercise. This is all revision. Let's draw a line graph. I've just copy and pasted the information as I need it into another page, and let's get started. So I've got here my horizontal vertical axis. I've divided up my horizontal axis into the 5 days of the week. So I'm just going to write that in. Just because my stylus isn't the best, I'm just going to write the first letter of the day of the week. Okay, now what I would like you to do as I set this up is to also draw yours, and then we'll get into plotting. Well, what you would notice first of all is that I've just gone up by 20s on the vertical axis. That is totally up to you what interval you choose to go up by. Okay, right. So on Monday, the price in cents was 45 cents. Okay, so I'm going to mark 45. If that halfway is 50, there's my 45. On Tuesday, 48. So just keep plotting. Wednesday, 55. So on Wednesday, there is 50, and halfway mark is 55. Thursday, we have 52. So just below the 55. Friday is 46. So on Friday, we have 46. Now, you'll notice that a lot of the values are between the 40 and 60 range. However, don't forget that your vertical axis must always start at 0 when plotting a line graph. Okay, now, drawing the dots, it's like dot to dot, starting from the very first point to the last point. Now, like for example 25, identifying misleading features of a line graph. This table shows the profits of a company over the 5-year period from 2013 to 2017. So here are 4 graphs, A to E, which represent this information below. What can you see is misleading about each graph? First of all, the first thing I could see with graph C that sort of springs to mind first is that, as I mentioned with all graphs, we should always begin the vertical axis at 0. So graph C doesn't. So it makes 2017 look as though they are 10 times greater than the profits in 2013. The remaining 3 graphs, they all do begin on the vertical axis at 0. So that looks correct. Okay, so looking at graph A again. Here, let's just have a look at these other 2. Yes, do they begin at 0? Correct. Now with graph A, are all the dates, all the years listed? Yes, they are, as per the table. Now if we have a look at the vertical axis, are they all going up by correct increments? So they're going up by 5s, and within each 5, are they going up by 1s as per grid line? So we've got 1, 2, 3, 4, 5. Yes, they are. Okay, so graph A looks okay. It's got all years listed as well as even intervals for both X and Y axis. Now looking at graph D. Graph D looks a little bit squashed. It doesn't have all years listed. Okay, so the data doesn't look as nice for say 2014 and 2016, and it does look quite squashed, doesn't it? So even though it does represent the data correctly, it does start at 0. it's harder to read. Graph E, it does also go up by 5s originally, but have a look at the scale here. There are a lot of inconsistencies between each grid line. So we've got 10, you can see the 10 marked here, and then it goes up by, the next grid line is 11, next grid line is 12, and then all of a sudden the next grid line is not 13, it's actually 12 and a half. So the point out was the actual grid lines themselves. If you notice with all 4 graphs, there are some sort of thicker grey lines and not so thick grey lines. Usually thick grey lines resemble equal markings or important markings or main times. However, if you look at graph E especially, you would notice that there is inconsistency of when the grid lines are thick and when the grid lines are thin. So that can be a little bit confusing. So moving on to the VCE question. The eggs laid by the female moths hatch and become caterpillars. The following time series plot shows the total area in hectares of forest eaten by the caterpillars in a rural area during the period 1900 to 1980. The data used to generate this plot is also given. Okay, so we've got a line graph here and we've also got a table. Okay, so the area eaten is in hectares. We've got year. It says, using the line graph above, complete the table and then use the data to comment what the statistician should be expecting for the value of 1990. Okay, so it's forecasting. If you can see 1990 hasn't been plotted, so it's forecasting what will happen next. We can see on the horizontal axis that the years actually go up by 20s, okay, and there is no dot in 1890 because there was no data for it. So the very first marking here is in fact 1900. Let me just change that pen. 1900, and then in between we've got 1920 and so on and so forth. On the vertical axis, we can see that the data does go up by 50s. However, each little marking represents 10 hectares. So let's look at 1920. What's the value for 1920? We can see that as we scroll up and move across, it's in fact 100 hectares eaten. And 1960, let's fill in 1960. So here's 1950. I'm looking at this line here, moving up to the dot and across. It looks like it is about 210, approximately 210 hectares. And in 1980, so there's 1970, this mark here would be 1980. Going up and across, looks to be 349 hectares eaten by caterpillars. Expect in the year 1990. Now, having a look at both the table and the graph, you would notice that between 1900 and 1970, there is, roughly speaking, a 20 to 30 hectare jump between each year. Now, I did say roughly speaking, because in 1900 to 1910, it's less than that. However, if we can assume that the data is correct and that there are no anomalies, from 1970 to 1980, there is a jump of 100 hectares. So we would expect that in 1990, there would also be a jump of approximately 100 hectares. So 340 plus 100, or 349 plus 100, like I said, we are roughly speaking. It's a prediction, so it doesn't need to be exact. So in 1990, we are looking at approximately 440 hectares being eaten. So year 11, at the bottom of the page, it says to complete exercise 7E. I will post 7E onto Google Classroom, and I would like you to do question 1, question 3, 6, 8, and 10 from 7E.